Welcome to this first video in a discussion of the ISLM model. The ISLM model has two parts, as the name suggests, the IS part and the LM part. And we're going to start by discussing the IS relationship. In particular, we're going to take three different views of this IS relationship. We're going to look at it algebraically, which gives us an IS equation. That's what we'll do in this discussion. Then we'll do a separate video where we talk about the geometry of the IS relationship. That would give us an IS curve. And throughout both videos, we're going to try to explain and discuss what we mean and what this IS relationship really means economically in plain English. And we'll start with that a little bit as background. So the starting point would be, what does IS stand for? Someone must have come up with this moniker for a reason, and what it stands for is investment savings. So we'll think of it as investment-savings. And once we put it in those terms, where have we seen a lot of discussion of investment and saving before, especially in the closed economy? And hopefully you think your first thought is, this is sort of related to loanable funds, right? So that's correct. This is about loanable funds. That's going to be our starting point, the loanable funds model. Alternatively, sometimes people talk about the IS relationship as being about the goods and services market or the product market. And what they mean by that is the LM market is going to be about money. It's not about actual production. Whereas the IS, because it's about saving and because it's about investment, and investment, we're really talking about physical production of housing and offices and factories and so on. The IS relationship is about goods as opposed to just money and financial instruments. So that's the first key point about IS. It's about investment and savings, which leads you to think, okay, the starting point is loanable funds. The second thing to notice is that when we talk about an IS relationship, it's got to be a relationship among two things, or at least two things. And so what I want you to keep in mind the entire time we talk about IS is that it's all about relating the variables R, the real interest rate, and Y, the real GDP. It's about relating interest and production. So when we talk about an IS equation, which is what we'll talk about on the next slide, what we mean is we need an equation that says R as a function of Y is something. How do you take Y and use it to calculate R? Equivalently, you could say, well, how could you take R and calculate Y? That would be fine too, but it turns out we're going to try to focus on it and getting an equation that says R equals and some stuff in terms of Y. So let's go ahead and try to do that. So our starting point will be, since we said we're going to start with the loanable funds market, we need to start with some investment equation and some savings equation. The investment equation we'll just use is 15 minus R, and it slopes down. As R increases, investment decreases. That relationship should make sense. We've seen that before. Savings, as you'll remember, is income minus consumption minus government spending. This is national saving. We haven't split it up into the two separate parts, public and private, because for the purposes of this model, that's not super important. And we could try to build up the equation for saving from Y and C and G. So if we started with equations for each of those, then we could get an overall expression for S. But we're going to skip that step today and just suppose that we've already found an equation for S. It's 0.5Y plus 2. But before we move on, I just want to think about, does this equation make sense? It says that as Y goes up, our savings will increase. Basically, for every extra dollar of income of GDP is produced, the savings will go up by 50 cents. Well, that seems, I don't want to say unreasonable. It's certainly an ambitious plan of saving, but it's not, it's reasonable enough for the purpose of simplifying calculations. It makes sense that as Y goes up, saving would go up. Although the 50 cent on the dollar ratio might be a bit high. I don't think you or I save that much of our extra income, most likely. All right. So now if we're talking about the loanable funds model, we'll need some equilibrium condition. And hopefully remember that equilibrium condition was that investment and saving have to balance. And the interest rate's gonna basically adjust to bring these two into balance. So if we plug in for I and S, we get 15 minus R equals 0.5Y plus 2. And now you can see we have a problem. If we were trying to solve for R or solve for Y, this single equation isn't going to be enough. If we knew one, we could get the other, but not knowing either means it's impossible to get either. So essentially what we do to get an IS equation is say, well, we don't know either of them, but we can at least relate the two to each other. Let's try to get all the Y's on one side, all the R's on the other. We sort of already did that, but we'll move the R to the right and we'll move everything else to the left. And what you get is 13 minus 0.5 y equals r, and that's what we call our IS equation. It does what we said we'd do, which is get a function that says r equals something in terms of y. So we'll label this is our IS equation. And then there's one last point to note. You might say, where's the IS in the IS equation? You know, thinking, isn't IS a variable? And that is important to note, it's not. IS isn't a variable. You'll never have a variable called IS within this equation. You did have earlier I and S separately, but even those we don't really keep because we substitute them out. We replace I with the 15 minus R, we replace S with the 0.5 y plus 2. So IS isn't a variable, like, if it helps, how D for demand isn't a variable. So when you have a demand equation, it's something like, you know, Q equals 10 minus 2P or something. There's a Q, there's a P, but there's no D variable in the demand equation. Similarly, there won't be an IS in the IS equation. All right, let's do one more application where we think about how this IS equation might change as different parts of the economy change. In particular, we're going to think about how changes in government spending could influence saving, and then as you can see, saving is part of IS, so it would influence IS presumably. So we'll start with what we had before, where investment is 15 minus R, but now we're going to modify the savings equation to say G is an unknown. We don't know G, so we can't plug it in. So that's going to give us this equation, which I just sort of made up, but it's consistent with not knowing G. It says saving is 0.5y minus 1 minus G. So as income goes up, we save more, but as government spending goes up, that's going to lower our saving. And that fits with the basic equation we have on the left of y minus c minus g. So let's set up our equilibrium condition like we did previously. We'll have I equals S. We'll plug in for I, that's 15 minus R. We'll plug in for S, that's 0.5y minus 1 minus g. Now we'll try to rearrange this so we get everything in terms of R, and I hope you're confident doing that, so I'll just give you the sort of final answer you get, which is 16 plus g minus 0.5y. So that's our IS equation. And what I want you to notice is that as g goes up, so we'll say G up, it would shift this up if we were plotting it out. We're not doing the geometry, but supposing we were, it basically is the intercept for this curve, so it would shift it up. So changes in G change the IS equation, thus they change the IS relationship. We'll also notice that G up will lead to R going up. And R going up will have all sorts of consequences in the economy. In particular, it's going to have effects on investment. So we're going to come back to that repeatedly in the discussion of the ISLM model, how changes in G or some other random exogenous variable will lead to changes in the endogenous variables like R and Y. All right, so thanks for watching. Hopefully I'll see you in the discussion of the geometry of the IS relationship in our next discussion.